On Thursday in stats, we started some basic rules of probability. We've already briefly discussed some rules, but what you see in front of you is the sample space for rolling two fair die. So for example, getting a 1 and a 1 is one possibility when I roll two die. Getting a 2 and a 1 is another possibility, and we have 36 possible outcomes. There's a clever way to figure out how many possible outcomes there are, and for each item, for each method of chance, you do a blank space, and you multiply in between, and you write how many ways each chance event can play out. So there's 6 ways for one die, 6 ways for another die, so 36 possible ways. So that's a nice, clever way to do it. But as you'll see in a second, the question that it asks after what you can see here, writing the whole sample space down is an important thing to do. It's not necessarily mandatory because some people can just intuitively see this in their head. But I don't know, myself, I like to write it all down. That way I can answer any question they ask about it. So what I'm talking about is, first of all, what is the probability of each outcome? And then next, probability of getting a sum of 5. So each outcome, if we assume these are fair dice, then each outcome is equally likely. So that means for any one outcome, there's a 1 in 36 chance. All right. They define event A as a sum of 5. So if I roll two dice, and they add up to 5, what is the probability of that happening? If you see all of your sample space, this is really easy. Just circle all the outcomes that add to 5. So like 4 and 1, 3 and 2, 2 and 3, and 1 and 4. And that's it. Skim through all the other outcomes, none of them add to 5. This can happen 4 different ways. Oops. Out of 36 possible ways. Or let's say total ways. 36, let's say that. So P of A is number of favorable number of A events, A outcomes, over total outcomes. So 436 is one way to write it. You could reduce it down to 1/9. You could even write it as a decimal. I guess you could write it as a percent. But anytime it asks for a probability or proportion, I usually leave it like one of these 3 here. I think they'll clearly ask for a percent if that's what they want. But, I mean, any of those are acceptable. When you look down on this page, it asks a potentially very difficult question, but knowing event A, finding the probability of event B is very easy. So first off, what's an event? You know, we already started to solve this thing based on an event A. This is a scenario that anyone can define. Another description, this is a scenario of interest. So, you know, if I am only interested in outcomes that add to 5, then I just decide I'm going to call this event A and define it and then find the probability. They could have said, we're going to call this event B or C or D, any letter. But then at the bottom of the page, they say, we're going to let event B be the sum not 5. So this is called a complement, because we already know a sum of 5 is A, so this is the complement of A. And they call it B. If you flip the page, it talks a little bit about complement events. But instead of adding up all the pairs of dice that don't add to 5, why not use event A? So can't we do something like this? And just say 8/9. Because all the events have to add up to 1, right? Or sorry, all the outcomes have to add up to 1. So if I know this is the exact opposite of event A, just subtract from 1. All right, we didn't go much further than this. We looked at a couple of the rules. At the top, you already know that stuff. Probabilities between 0 and 1. All these outcomes need to add up to 1. The only other thing that I really pointed out was this complement rule, number 4. A plus not A has to be 1.0. Notice they can say not A, the complement of A, in different ways. They could use a little tick mark. They could use the letter C. I typically see it with, I don't feel like I ever see this one, but it could happen. But it's a very handy rule to remember. All right. And that was as far as we went. We'll talk more tomorrow. Bye, y'all.